class today. My name is Neyedu Godwin and I'm your regular anchor. Today we're going to be discussing quality assurance and quality control in ultrasound. Before we begin, I want to acknowledge these wonderful people who have contributed greatly to my knowledge. Now, what is a quality assurance program? Now, this program consists of essential tasks and activities in the diagnostic ultrasound department. It is to ensure proper operation of the equipment, to eliminate misdiagnoses, to reduce number of repeated examination, improve cost efficiency, Now, within good quality assurance program, the activities are preventive maintenance of the equipment calibration for optimal performance, optimizing operator and patient safety, in service education, that is in-service education and training, specification for acceptance of protocol for testing, evaluation of new products. What is a quality control program? The function of a quality control program is to help ensure consistent final image by detecting any changes in equipment performance and having necessary repairs done. So a quality control program is achieved by monitoring and testing equipment at certain time intervals. Also determine equipment operational consistency through time by measuring equipment response to known test standard. So whose responsibility is it to do the quality assurance, the quality control in the department? Good quality assurance, quality control typically involves the following individuals, and the number one of those individuals is the sonologist or the sonographer. And basically what it does is to assess image quality, to direct scanning protocols, is to perform some routine testing and record keeping, to perform routine basic maintenance, and this can be done daily, weekly or monthly. The second in line is the service personnel, and the service personnel is to assess image quality, to perform diagnostic testing, to perform some routine maintenance, to repair malfunction equipment, and to maintain service records. So what are the components of a quality assurance program? I can tell you that there are three basic components of a good quality assurance program. The first is routine preventive maintenance. The second will be routine performance test, and the third is acceptance testing. The routine preventive maintenance, now these are tasks that can be performed by a sonologist or a sonographer on an ongoing basis to minimize the opportunity for equipment malfunction, and this will include to assess the visual integrity of all transducer and cables, to clean equipment surfaces, dust monitor camera surfaces if it's accessible, monitor and adjust recording devices, to clean scanner exhaust fan filters, processor quality assurance where it's possible. The routine performance testing may be performed by a sonologist or a sonographer, or even the service engineer. Basically, the routine testing at a fixed time interval will be around maybe every 3 weeks or every 6 months or thereabout, to assess that the equipment is performed consistently. This is done using the test object like phantoms and standardized system parameters. The relative change in test values over time is monitored and requires regular and accurate record keeping. Acceptance testing is not performed by the sonologist or the sonographer. It's performed by a qualified personnel on new equipment prior to its first use. So quantitatively measures the equipment parameters such as power output to ensure that the accepted government or regulatory standards are met, and uses test objects such as a phantom and other sophisticated testing equipment such as hydrophones, force balances. So why should a quality assurance be performed? It depends on the specific aspect of quality assurance program. For example, assessing the integrity of a transducer and cable is a component of routine preventive maintenance, which can be performed by the sonologist or the sonographer on a daily or weekly basis. So assessing the transducer performance such as axial and lateral resolution or caliper check, depths, calibration, etc. using a test object or tissue equivalent phantom every 6 months is part of the routine performance testing. Acceptance testing is usually performed when new equipment arrive and is being installed by the engineer. The devices that are used in ultrasound quality assurance program can be classified among many into two broad groups. The first is device used by the sonologist or the sonographer. The second group is device used by the service personnel. Now, the commercially available devices that are used by the sonologist or sonographer to test imaging performance based on established criteria that is set by the AIUM 94, 95, 96 are as follows: the AIUM 100 mm test object, the tissue equivalent phantom, a Doppler device, which include a Doppler flow phantom, Doppler string phantom. Other testing equipment are typically which are typically not used by sonographers or sonologists are the SUAR test object. SUAR stands for sensitivity, uniformity, and axial resolution. The other one is a test generator, or the pulse burst generator, or is also called electronic test object. The third is radiation force balance. Then you have the fourth, hydrophone, fifth, spectrum analyzer, sixth, calorimeter. Now, the AIUM 100 mm test object has been developed by the American Institute for Ultrasound in Medicine. It is a plexiglass box of fluid with stainless steel rods fixed within it. Yeah. Now, the fluid is degassed. The fluid is degassed water that is mixed with algicide, that is algae in a beetle, and 9% alcohol at 22 degrees centigrade or room temperature to bring its propagation speed to 1,540 meters per second, which is the velocity of sound through soft tissue, which also the equipment calibration is based on. Although it is designed for an A mode and static B mode image system, it has been used to test real-time ultrasound scanners. AIUM 100 mm test object can perform the following quality assurance tests. Sensitivity. The minimum is used to test its minimum sensitivity test. It's also normal sensitivity tests like axial resolution, lateral resolution, dead zone, range accuracy or depth calibration, caliper check. Uniform testing is part of what it performs. Beam profile is also included. So the AIUM test object does not provide the attenuation and or scattering properties of tissue. So it cannot be used to test tissue characteristics or grayscale information. AIUM test object cannot evaluate or test for the following: lesion detection, also called detail resolution or grayscale. It cannot evaluate for slice thickness, dynamic range, cyst fill in, accuracy of velocity measurement, range, gate placement, and several Doppler parameters. It doesn't do that. Tissue equivalent phantom, TE phantoms. These are the most commonly used testing devices today. It provides much more realistic assessment of clinical performance than the AIUM test object. It gives accurate assessment of grayscale or tissue characteristics such as attenuation and scattering. In addition to all the parameters that can be checked with AIUM test object, TE phantoms provide the assessment for lesion detection, TGC characteristics, slice thickness, dynamic range, cyst filling, sensitivity, normal sensitivity tests like the axial, lateral resolution, dead zone, range accuracy or depth calibration, caliper check, uniformity test, beam profile. Now, a tissue equivalent phantom is a plastic box containing material that simulates the acoustic property of soft tissue. Now, this usually consists of mixture of gelatin and graphite powder. Within this tissue equivalent material, a pattern of wires and or cysts and solid targets are used to generate echoes. Now, many different patterns are available. A TE phantom attempts to mimic the interaction of ultrasound in human body to mimic soft tissue and thus better present a clinical situation. It has several of the characteristics of soft tissue such as propagation speed, scattering coefficient, attenuation coefficient. Now, TE phantom will propagate sound at speed of 1,500 meters per second. It has an attenuation coefficient of 0.5 decibels per centimeter per megahertz. You have scattering property that is closely mimic soft tissue. That is on display. The image from a TE phantom resembles scattered echo pattern from the liver. A TE phantom are available, or rather are able to assess the axial and lateral resolution, system sensitivity, TGC characteristics, and dynamic range. Some TE phantoms are specially designed to assess slice thickness resolution, like elevation resolution, contrast resolution, and lesion detection. Quality assurance tests includes sensitivity. And sensitivity is the ability to detect and display weak echoes. Now, when the system is adjusted to display the weakest echo possible, we refer to this as a maximum sensitivity. It is a measure of minimum gain setting required to produce echoes on display from a specific interface. A change of 6 decibels or greater over time indicates a need for service. I'll take that again. A change of 6 decibels or greater over time indicates a need for service. Sensitivity depends on several parameters: the receiver gain, the output control, the dynamic range, the reject control, and the transducer. Transducer with good sensitivity requires less output power or receiver's gain to display weak echo. This sensitivity can be measured both with AIUM test object and TE phantom. Now, using the AIUM test object, the sensitivity is measured by using the last pin in group C with transducer position on a face A. Now, the record is made of the machine setting, which include output, power, overall gain, TGC slope, which required to barely display on the bottom pin rod in E, and is documented. Now, if the system sensitivity is changed, these settings should be consistently result in a similar image on future tests. Now, an increase in the overall gain setting requires to produce a comparable image, which indicates a loss of sensitivity. An increase in the overall gain setting required to produce a comparable image indicates a loss of sensitivity. To check sensitivity with TE phantom, the output gain and TGC settings are adjusted to obtain maximum penetration in phantom. A hard copy of the scan is taken and the depth penetration is measured and recorded. Now, using the same setting, the same penetration should be seen on the future test. A loss of penetration indicates a lower sensitivity. Now, uniformity this is a test of uniformity in linear array. A uniform interface should produce uniform linear echo display. The gradation of this uniformity may indicate an inconsistency between array elements, that is the crystals, and can be measured with both the AIUM test object and the TE phantom. Uniformity should be evaluated at the startup. This can be done by looking for linear dropouts in the near field, which may indicate inactive crystals. Inactive crystals can cause image degradation and reduce penetration, especially when large patients are being imaged. Now, dead zones, this is synonymous to ring down zone or ring down space or main band area of reverberation. Now, it measures the distance in the extreme near field in which no useful anatomical information can be obtained as a result of the ringing of the transducer following electrical stimulation. That is, it is the length of the near field where no anatomical structure is imaged. The dead zone runs from the transducer face to the first identifiable echo. The dead zone varies with transducer type due to pulsing system and backing material that is used in the transducer. Dead zone should not exceed 4 mm for most transducer and 1 mm with modern sophisticated array transducer. The smaller the dead zone, the better the resolution, and the less real anatomy is lost to anterior reverberation. It can be measured with AIUM 100 test object and TE phantom. The dead zone deals with the topmost rod group and is measured from the top of the test object to the first clear defined rod. The axial resolution is synonymous to longitudinal, axial, range, radial, or depth resolution. It assesses the minimum distance that penetrates two inner faces along the length of the beam, that is parallel beam back and forth, and can be measured with both the AIUM 100 test object and the TE phantom. Lateral resolution is synonymous to lateral, angular, transverse, azimuthal resolution. and assesses the minimum distance that penetrates two surfaces across the beam perpendicular to the beam side by side, and can be measured with both the AIUM 100 test object and TE phantom. Range accuracy is synonymous to depth calibration accuracy. Assess the ability of the system to accurately position echoes along the length of the beam. The acceptable range is plus or minus 2% accurate and can be measured with AIUM 100 and TE phantom. Now, the horizontal accuracy is synonymous to lateral accuracy and measures the accuracy of the system to position echoes laterally, and the acceptable lateral accuracy is plus or minus 2% and can be measured with AIUM 100 and TE phantom. Beam profile. The shape of the beam is assessed, and this can be done with variety of equipment. This includes the AIUM 100 test object, the TE phantom with appropriate rod group, hydrophone attached to a plotter, most commonly used most commonly used in clinical practice. The beam profile phantom, most sophisticated testing. Lesion detection, synonymous with detail resolution. The ability of a system to detect small cystic or solid lesion. This can be assessed by using TE phantom that contains a range of small cystic and solid lesion. Slice thickness. This the dimension of the beam perpendicular to the plane of the section is actually the slice thickness, and is also known as the Z axis or the elevated axis. Now, slice thickness can be measured using slice thickness phantom, which incorporate about 45-degree angled scattering plane. Slice thickness for various depths can be measured. It can also be measured using spherical void phantom. Doppler device. A few commonly measured parameters are system sensitive, accuracy of velocity measurement, accuracy of range gate placement, and several color Doppler parameters. Now, TE phantom and fluid mimicking phantoms are the best. However, they are expensive. So, Doppler strain phantoms are simpler and less expensive. Equipment cleaning, disinfecting, and sterilization. Cleaning is the removal of soil and thus the reduction of microorganisms from a surface. Cleaning can be achieved by washing with soap and water or wiping with 70% alcohol. It is the essential first step to either disinfecting or sterilization. Cleaning is appropriate for transducers used for normal transabdominal scanning. Disinfection is the inactivation of vegetative bacteria, virus, fungi, but not necessarily of bacterial spores. Disinfection is required for minimum risk medical instruments, including those used in contact with intact mucous membrane like the transvaginal transducer. Before disinfecting, instruments should be cleaned properly with water and a small amount of soap. Dishwashing liquid works very well, and then dried with soft clothes or paper towel. Next, the transducer should be disinfected with the use of liquid chemical germicide according to manufacturer's direction. Commonly used disinfectant includes 2.4 to 3.2% glyceraldehyde products such as the Cedex, metricide, or Procide. Glyceraldehyde products are classified as irritants and are usually toxic to healthcare workers and patients, but not known to be carcinogenic or teratogenic. Care should be taken when you are using glyceraldehyde products. Sterilization is the complete destruction of microorganisms, including bacterial spores. It is generally achieved by autoclaving, that is steam under pressure. However, this procedure must never be used with an ultrasound transducer, since the heat will permanently damage the piezoelectric properties of the transducer. Gas sterilization with ethylene oxide can be an alternative. So sterilization is required for a high risk or critical medical procedure involving penetration of the skin, membrane, or other tissues. For example, oocyte harvesting, chronic villi sampling. So in summary, a simple method of maintaining sterility is to cover the transducer and cable with a sterile sheet. This is the most common approach when ultrasound is used in the operating room. Transducers for standard scanning procedure like abdomen, pelvic, cardiac should be cleaned with soap or dish washing liquid and water, then dry with soft cloth or paper towel. Cleaning with soap and water does perfectly fine. Alternatively, a spray bottle with a cleansing solution such as Hydrox or 70% alcohol can be used. Now, single-use sterile scan gel packages may further reduce the likelihood of cross contamination. Now, statistical indices. Statistics is the science of collecting and interpreting quantitative information. Now, the information is called data. Most researchers and journal authors will do statistical analysis on their results. Now, some common statistics used to evaluate diagnostic tests like sensitivity, specificity, positive, negative predictive value, and accuracy. Now, to assess the quality of diagnostic tests, it needs to be compared to the gold standard. And the gold standard is the test that gives a definitive result. For example, a biopsy and a cytological diagnosis for tumor or on enhanced CT for diagnosis of renal stone is now considered gold standard. When a test is compared with gold standard, the results will fall into one or more of the following categories. A true positive. Now, this is the result that was positive on the test and also positive on the gold standard. This is a good result. A false positive. This is a result that was positive on the test but negative on the gold standard. This is not a good result. Disease was detected where no disease existed. It is an overcall. A true negative. This is a result that was negative on test and negative on the gold standard. This is a good result. A false negative is a result that shows negative on the test but positive on the gold standard. This is not a good result. Disease was not found where disease actually occurred. It is a miss. Now, sensitivity is the ability to test, to find disease where disease or when disease is present. A test is sensitive when it does not miss the disease. It has a high true positive rate and a low false negative rate. Specificity is the ability of a test to indicate no disease where there is no disease present. A test is specific when it does not overcall disease in a patient who do not have the disease. It has a high true negative rate and a low false positive rate. Positive predictive value, PPV, is a measure of how likely it is that a disease actually is present when the test result is positive. It has a high true positive rate and a low false positive rate. Negative predictive value, NPV, is a measure of how likely it is that disease is actually present when the test result is negative. It is a high true negative rate and a low false positive rate. Accuracy is the ability of a test to give correct answer. The most accurate test would have a high sensitivity a high specificity and a high PPV and a high MPV. I want to thank you for joining this lecture today. I'm sure you've learned a great deal in ultrasound physics classes, and I would like you to share, to like and subscribe. Put on your notification to receive all the free lectures. And for more information about our paid classes, please send an email to sonoeyesdiagnostics@gmail.com, or you can WhatsApp me at +234 9019 144 175, or you can visit our online store at sonoeyes.business.site. Attempt the quiz in the description and leave me a comment. Until the next time when I come your way again, keep learning ultrasound.